So as we continue this morning at the Hilton at 5711 West Century Boulevard, 11th floor, room 1137, we're continuing with our amazing 5-concept matrix and circuit analysis via the mesh method. And your host, yours truly, Dolphy Gilpin. So as we continue now, we said that we have used the components breakdown from the amazing 5-concept matrix, from which we had 4x4 breakdowns, 3x3 breakdowns, and 2x2 breakdowns. And previously we just used a 2x2 breakdown to demonstrate a 2x2 circuit analysis. And here we know we have a 3x3. So let's just get right into it. So we have synthesized now a 3x3 circuits here. And once again, we have to be able to move from the metrical representation into the linear representation and vice versa. So we have the circuit here now, and we have mesh 1, mesh A, mesh B, and mesh C, or mesh 1, mesh 2, and mesh 3. And we have the voltage and the currents, loop currents, IA, IB, IC, and the voltage now, 15 volts, and for the V source, 1 volts. Now in our analysis, now we use the KVL or the Kirchhoff voltage law equation for mesh A, B, and C. And we say now that mesh A, we have V1 plus V2 is equal to 15 volts. 15 volts here. And this is the voltage here. For mesh B, which is here, we have now that V4 plus V source is equal to 15 volts. And for mesh C, we have now that V2 plus V3 is equal to V4. Now I1 is equal to minus IA, and this gives rise now that V1 is equal to 10 kilo ohms times I1. I2 likewise is equal to IC minus IA, and this gives rise now to that V2 plus 5 kilo ohms times I2, which is equal now to 5 kilo ohms times IC minus IA. I3 now equal to IC, and this gives rise now to that V3 is equal to 10 kilo ohms times I3. That is using V equals IR. We're using KVL, Kirchhoff voltage law, and the Kirchhoff current law, in combination with Ohm's law, and that's equal now to 10 kilo ohms times I2, or rather IC. Now I4 is equal to IB minus IC, which yields now V4 is equal to 5 kilo ohms times I4. This will equal now to 5 kilo ohms times IB minus IC. And last, we have now that I5 is equal to IB minus, which yields now that V source is equal to 10 kilo ohms times I5, and that's equal now to 10 kilo ohms times I3. So at mesh A now, we have now that 10 kilo ohms times plus 5 kilo ohms times IA minus 5 kilo ohms is equal to V source 1. And mesh B now, we have now that 0 plus 10 kilo ohms plus 5 kilo ohms times IB minus 5 kilo ohms times IA is equal to V source 1. And for mesh C, we have now that minus 5 kilo ohms times IA minus 5 kilo ohms times IB plus 5 kilo ohms bracket plus 10 kilo ohms plus 5 kilo ohms is equal to 0. And we translate now the linear or the standard equation now into the matrix form, and we have now, this would be a representation of the rows and column R11, R12, R1 tree, R21, R22, R2 trees, rows and columns now, and R31, R32, and R33. And for this corresponding R11, we have now that 10 kilo ohms plus 5 kilo ohms, which would represent now this mesh one here. 10 kilo ohms plus 5 kilo ohms. Here's a 10, and here's a 5. And at R11, R12 will be equal to 0. R12, there's no current here in 1 and 2. So this is 1, and this is 2, and this 0 current. Resistance rather. And R13 is equal to minus 5 kilo ohms. The resistance common to 1 and 3 here now. 1 and 3, which is this one here, which is 5 kilo. R21, 0. R12 and R21 is the same. And R22, 2 and 2 now, would be equal now to 5 kilo ohms plus 10 kilo ohms. That's equal now to 15 kilo ohms. And R23, mesh 2 and mesh 3, two and 3, which is this one, which will be equal to 5 kilo ohms. So we're putting in the elements, rows and column, and R31 would be equal to minus 5 kilo ohms, R32 equal to minus 5 kilo ohms, and R33, 3 and 3 will be equal now to 5 kilo ohms plus 10 kilo ohms plus 5 kilo ohms. And that's equal now to 20. And this will be now times IA, IB, and IC. And that will be equal now to minus 15 volts, 15 volts, and 0. Now if we solve now, we would have known that IA, IB, and IC is equal to minus 10 milliamps, 1.0 milliamps, and 0.0 milliamps. And we could also use a graphing calculator or matrix software, and we solve for these IA, IB, and IC. Now calculating the device voltage, we use Ohm's law, and we say now that V1 is equal to R1 I1 using V is equal to IR or V equal to RI. And that's equal to 10 kilo ohms now times 1 milliamps, and that's equal to 10 volts. V2 is equal to R2 I2, that's equal now to 5 kilo ohms times 1 milliamps, that's equal to V2 is equal to 5 volts. And V3 is equal to R3 I3 is equal to 10 kilo ohms times 0 milliamps, that's equal to 0 volts. And V4 is equal to R4 I4 is equal to 5 kilo ohms times 1 milliamp, is equal to 5 volts. And V5 is equal to RS I5 will equal to 5 kilo ohms times 1 milliamp is equal to 10 volts. That is V5 equal to R5 I5 equal to 10 kilo ohms times 1 milliamp is equal to 10 volts. So here we have now completed the 3x3 circuit analysis, and we have represent the components in the linear fashion and also in the metrical representation. Now we are using the Amz5x12 matrix, so we are associated now the components breakdown for the Amz5x12 matrix, and we have used these components to synthesize a 3x3 mesh circuit and with loop currents IA, IB, and IC with 3 meshes, 1, 2, and 3, mesh A, mesh B, and mesh C, or you could call it mesh 1, mesh 2, and mesh 3. So that is all now our 3x3 metrical representation, and we derive it now from the breakdown residual components of our Amz5x12 matrix. And so this is one application now in circuit analysis, and whereby we just have to use our intuitive knowledge of our circuits, Ohm's law, Kirchhoff voltage law, and Kirchhoff current law to complete the analysis. So we'll take a break here and then we'll return with some other